Okay, today we're going to be talking about three topics related to numeric variables. Those are arithmetic expressions, constants, and casting. Okay, so in terms of arithmetic expressions, what I mean by that is if you have a numeric variable, we're going to be focusing on variables of the int and the double type. So when you have such a variable, usually you want to compute some sort of mathematical quantity, some sort of arithmetic expression. And in order to do so, you need to know how to use the arithmetic operators, addition, subtraction, so on and so forth, in Java. So as we've already seen, kind of in line with what you'd expect, the plus symbol on your keyboard is how you would perform addition. The dash on your keyboard is how you would perform subtraction. The asterisk is multiplication. And the / is division. In addition to these four basic operators, there's also the remainder operator. That is the % sign on your keyboard. So this is the remainder operator, also known as the modulus operator. And then last but not least, you can also use parentheses just like you would in algebra to enforce order of operations. So if you put parentheses around a quantity, that quantity will be evaluated first, and we'll see an example of that. Okay, most of these operators, so addition, subtraction, and multiplication work just as you would expect them to work. Let's look at division a little bit more closely, because once you specify the type of something, whether the type of a variable or of a numeric literal, then division becomes not as obvious. And so I have some examples here. Okay, so here I have 4 different examples of performing division. And let's see, the first one is probably the most kind of normal expression. Okay, so on the right-hand side, we have 2 floating point numbers, 15.5 and 4.0. When you do the division, it's just normal division. There's nothing special going on here. The computer evaluates this expression, and then it stores the answer in this variable of type double. Okay, so the answer is 3.875. Okay, so at the end, the variable ratio holds the value 3.875, and that's basically it. Okay, down here in the second example, what I've changed is now the variable where you're going to store the answer has type int instead of type double. Now this is problematic because when we do the division here, right, the answer is 3.875, and that's a floating point number. So when you try to store it into this variable of type int, you will in fact encounter an error. Okay, so the computer will not let you do this. If you want to force the computer to do this, it would require what's known as casting. So that's one of the topics of this lecture, and we'll talk about that. In this case, if I did want to make the computer take a value and force it down into a variable that has less precision, how would I do that? And that's known as casting. Okay, in this next example here, now I've changed the right-hand side. So instead of having 2 floating point numbers that we're dividing, we have 2 integers. So in Java, actually in most programming languages, when you're dividing 2 integers, this is known as integer division. And integer division truncates the answer after the decimal place. So here the computer computes 15 divided by 4, and that's 3.75. it will then truncate, leave the 3, and that is what gets stored in the variable ratio. So when you're doing division, the very first thing you need to consider is, what am I dividing? If you have both integers, then you need to keep in mind this is going to be integer division. If at least one of your operands or both are floating points, then you don't need to think about it, it's just normal division. Here now I have the same on the right-hand side. We have 2 integers. Since both operands are integers, again, this is integer division, so that 3.75 gets truncated down to 3. And now I'm storing that into a variable of type int. So the difference between these last 2 examples here really happens when you store the answer. Okay, so if we were to print out kind of here, if we were to print out ratio, we would see that it would print 3.0. So at the moment that I take this integer 3 and I store it inside of ratio, I'm doing a conversion. It's known as an assignment conversion. I'm converting the integer 3, which was our answer, to the floating point 3.0. Here, there's no sort of assignment conversion going on. So I'm performing integer division. That gives me an integer, and I'm storing it in an integer. If I was to print this, it would say 3. Okay. Now, the last thing I also wanted to note is I'm assuming that each of these lines of code is that they are independent of each other. In other words, these aren't all in the same file. What I mean by that is, if I have a variable here called ratio that I declare, and then in the next line of code, I try to redeclare it as an int, the compiler will throw an error because you can only declare a variable once. From that point on, it's already been declared. You cannot redeclare it. Okay, so in this example, imagine each of these expressions being in its own file. Okay, they're independent of one another. Okay, so just to summarize, for division, if both operands are integers, then it's going to perform integer division. And just to be explicit, that means that if at least one operand is floating point, I'm going to abbreviate that FP, then it's performing normal division, by which I mean the division that you're used to. Okay, so that's division. And again, we'll come back later and we'll talk about this example, which is casting. And we also here saw an example of something similar to casting, which is assignment conversion. The moment I took that 3 and stored it into a double, it is converting it from the integer 3 to a floating point 3.0. Okay, let's talk a little bit about the remainder operator. So the remainder operator, which is the percent sign, returns the remainder after division is performed. So for example, let's go back to 15 and 4. So if we had int remainder equals 15 mod 4, what is happening is that this division is being performed. So 15 is being divided by 4. And what's being returned back to you is the remainder, what's left over. Okay, so for example, go all the way back to elementary school when you learned how to divide. I don't know about you, but I remember, you have the house and we put 15 under the roof and, we put 4 out here. You do the division, right? 4 goes into 15 3 whole times. Okay, you do your subtraction. and we have 3 left over. So, you know, in the good old days before you knew about fractions and decimals, you were done. You would just say 3 remainder 3. Okay. That remainder is what's being returned by the remainder operator. Okay. So here, right, the answer is 3. So 15 mod 4 is 3. 4 goes in some number of whole times, and the remainder is 3. Okay, looking at another example, let's say that we did, right, 25 mod 6. So let's say remainder equals 25 mod 6. Okay, so again, think back to basic division. How many times does 6 go into 25? It goes in 4 times, right? We do the division, sorry, we do the subtraction, and we get a remainder of 1. Okay, so this evaluates to 1. Now, it's not really clear why this is useful. We don't often need to compute the remainder of the modulus in everyday life, but you'll see this is useful for isolating digits. So for example, if I had a number 356, I could mod this by 100, and that would give me these last 2 digits, 56. And then I could mod that by 10, and that would give me this last digit here, 6. So actually, I think either in a lab or homework assignment, you'll basically be using the mod operators to do this. So that's one thing, is isolating digits. Also, it's useful for testing for even or odd. Okay, so you can mod a number by 2. The remainder will either be 0 or it will be 1. So you can test the remainder to figure out if the number you're working with is either even or odd. So those are probably the main 2 uses of the mod operator: taking a number and decomposing it down into its digits, or testing something to see if it's even or odd. Okay. Next, I want to talk quickly about constants, and then we'll stop and just look at some code examples. So sometimes you'll have a variable whose value does not change during the program. Okay, so you'll create a variable, you'll give it an initial value, and from that point on, that variable will never change. It will always hold that value. In that case, you might think about changing from a variable to what's known as a constant. Okay, so constants hold the same value for the duration of the program. When you create a constant, you use very much the same syntax as you would for a normal variable, but there's a new keyword called the final keyword. So if I wanted to create a constant, for example, final int num students, and in this class, the number of students is 24, and it's always 24. So I don't anticipate that number changing anytime soon. So here's how you would declare and initialize a constant. It looks really similar to the way that you would declare and initialize a variable. Some of the difference here, so this is a special keyword that lets the computer know this variable is a constant. In other words, this variable is final. I have given it a value, the end. It will not change. Notice also that we use upper caps and underscores. The reason that constants are written using uppercase and underscores is so that if someone's reading your code, they see a variable, they know, oh, this must be a constant, without needing to see where it's declared. Okay, so even if you declare the constant at the top of your file, and I'm reading 500 lines down below, I don't have to scroll all the way back up to figure out, is this a constant or not? Just by looking at the variable and the way that it's spelled with all caps and underscores, I know, oh, okay, this must be a constant. Okay, and then here we have an initial value. Because this is a constant, you have to give it an initial value, otherwise the compiler will throw an error. So you do not have the option of declaring it and then at a later date assigning it a value. If I was to later in my code try and change it, so num students equals 30, the compiler is going to throw an error. Okay, so one of the nice things about, that's weird. One of the nice things about declaring a variable to be a constant is now the compiler will help you make sure you never change it, and it will throw an error if you do change it. So some of the reasons, I guess, for using constants, technically you don't have to. So if I had a program and I wanted a variable to hold the number of students, you could just have a normal integer variable. There's nothing special about this value 24. It really is just an integer. But some of the benefits to indicating or marking that a variable is a final are A, the compiler will now help you make sure that you don't change it. B, you're being very clear about your intentions for anyone who comes after you and reads your program. And then C, and this is less about making your variable final and more about just having a variable in general. Anytime you have a number like 24, rather than using the number in your code, create a variable. Give that number a name, a description, and then use the variable throughout your code. That way, when someone's reading your code and they see the number 24, they're not sitting there like, what is 24? Is that hours in a day? What is 24, right? I've given it a name. It's the number of students. And that way, anyone reading my code knows what that number means. And then lastly, if the number of students really does change, I can go ahead and change that in my code. Not here, but up here when I declare it, I can go ahead and set this to 30. And that's all I have to change. If, however, you have the number 24 throughout your code, then you have to find every instance of 24 and you have to change it. And that's kind of a headache. Okay, so let's stop now and just look at some code examples. So here I have a empty class and wanted to look at just converting various quantities from the imperial system to the metric system and writing code to do that. So the very first example will be, let's see what I have, converting, let's see, Fahrenheit to Celsius. And the equation for doing that is that Celsius times, okay. So if you have a temperature in Fahrenheit, so today maybe it's 50 degrees, and I want to know what is that in terms of Celsius, then you would subtract off 32. Again, it's not clear why 32. So we're actually going to make a variable for 32 because there's a reason. 32 is the freezing point. So we're going to scale down or subtract off the freezing point and then multiply it by this conversion ratio 9/5. Nope, 5/9. Okay. Okay, so let's say that I wanted to take a Fahrenheit value, implement this equation, convert it to Celsius, and then print it out. So the first thing I probably would do is create constants for these two values. They're not going to change in the duration of my program. In fact, they're probably not going to change beyond my program because they are constants in our physical world. So that's always comforting to know. Okay, so let's do final int freezing point equals 32. And final int, let's see, Celsius ratio equals 5 divided by 9. Okay, so I want to stop here because I've already made an error, and this is a really common error that I see students making a lot, and you have to be really careful. So going back here, we're performing integer division. 5 is an integer, 9 is an integer. So this is going to compute 5 divided by 9, which is 0 point something something. Then it's going to truncate, and the answer is just going to be 0. Okay, so if you're not careful, you're going to, actually, if you did this, you would know because every time you ran your program, when you printed out Celsius, it would always be 0. And at that point, you know, okay, I have some sort of error, what's going on, and don't forget about integer division. So at least one of these operands has to be a floating point. It doesn't really matter which one you make a floating point, and you could make both of them a floating point. Okay, the other error that I've made here is now that these are floating points, this is going to give me a floating point answer, and I'm trying to store it into this integer. There's no need to do that. This really should be of type double. Okay, now I can have my Fahrenheit value. So let's say that I'm interested in converting, thank you. I'm interested in converting 50 degrees Fahrenheit, and I want to know what would that be in terms of Celsius. So looking at our equation, I'm going to use parentheses to enforce order of operations. So take the freezing point, no, sorry, take our temperature in terms of Fahrenheit, subtract off the freezing point, and multiply by the Celsius ratio. Okay, so that's what our equation tells us to do. So here I'm using these parentheses because I want the subtraction to happen first. Without the parentheses, this multiplication would happen first. Okay, and again, that just kind of lines up with normal algebraic rules. So PEMDAS, please excuse my dear Aunt Sally. So I'm using the parentheses here to say, please do the subtraction first, then go ahead and multiply. Okay, so we can print this out, system.out.println. So let's see, degrees Fahrenheit is equal to degrees Celsius. So when this prints out, I should get 50 degrees Fahrenheit is equal to something degrees Celsius. Okay, so let's go ahead and compile. No compilation errors, and we can run it. And here we go. All right, so 50 degrees Fahrenheit is equal to 10 degrees Celsius. Now, when you're, especially because this is a well-known mathematical equation, one thing you can do to make sure you don't have any errors is you can test values that you already know. So for example, 32 degrees Fahrenheit should be 0 degrees Celsius. 32 degrees is the freezing point of water in Fahrenheit. 0 degrees is the freezing point of water in Celsius. So knowing that, I can kind of use that as a little test of my code. And there we go. Okay, so 30 degrees Fahrenheit is equal to 0 degrees Celsius, so that looks good. Okay, so notice that if I want to run this program multiple times and convert various temperatures, I have to manually change the code. Okay, so maybe now I want to know what 100 degrees Fahrenheit is. Actually, I'm kind of curious. 37, okay. So it would be nicer, instead of having to manually change this number each time I'm interested in converting a different temperature, it would be nicer to have a program that was interactive, that when we ran it, it would just ask the user, like, what temperature are you interested in converting? And then I could type it in, and then the program would execute with that value. And in the next chapter, or in the next upcoming lectures, we'll learn how to do that, how to make an interactive program. For now, though, we would have to manually modify the value of this variable. Also, notice that that's why I didn't make this variable a constant. Technically, the value of Fahrenheit is not changing when I execute this program, right? Like I manually change this to 100, and then I execute it, and there's no code later on to change it to some other number. However, I felt like philosophically, the reason I wouldn't make this a final, even though it holds the value 100 for the duration of the program, is my intention as a programmer is for someone to come in here and to keep modifying and updating this every time they want to convert a temperature. So although technically it could be a final variable, philosophically, it's not. Okay, philosophically, it is the variable that you change so that you can rerun this program and get the information you want, for whatever that's worth. Okay, so let's do another one. So let's convert from pounds to kilograms. This conversion is much easier. Really, there's just a conversion ratio that you multiply by. It's kind of a long one, 0.453592337. Okay, so if we had some amount in pounds, like 50 pounds, and we wanted to know what that would be in kilograms, we could take the pounds, multiply it by our kilogram ratio, and then print that to the screen. So pounds is, let's say, is equal to. Okay, so let's compile and run this. Okay, so 50 pounds is equal to 22.679 kilograms. Okay. Again, if you wanted to convert different pound amounts to kilograms, you would have to manually come in here and change that. In the next few lectures, we'll look at how to do an interactive program so that no one has to manually modify your program. Okay. Okay, last but not least, I wanted to talk about casting. And let's see. So casting, I'm going to start by giving a definition for what it is. So casting is anytime you change the type of a value. I'm going to put in parentheses of a value, not a variable. What I mean by that is when you create a variable, when you declare it, you specify the type. From that point on, the variable is that type. There's no changing the type of the variable. However, a value, right? In other words, a numeric literal, a number, or we did some sort of computation and we finally have a result 3.875 or whatever. The value, the type of a value can change, and changing the type of a value is known as casting. Now, your book talks about 3 different ways. Okay, it's not known as casting, it's just changing the type. Your book talks about various ways of changing the type of a value. One of them we've already seen. So here, go back one more. So when I took this integer 3, stored it into the variable of type double, that's an assignment conversion. It's going to take the integer 3 and convert it into the floating point 3.0. That's an example of changing the type of a value. One of the other ways that you can change the type of a value is by explicitly casting. Okay, so when you cast something, you're going to tell the computer the new type of the value. Okay, so here's an example of me casting a value. So let's say I have int total equals 50. And double result equals, okay, total divided by 6. Okay. So this is an explicit cast. So here, total is an integer variable, 6 is an integer variable. Without this cast here, we would be performing integer division, and we're going to be truncating the answer. If you don't want that to happen, at least one of these operands has to be a floating point number. So one way you could do that is you could change the 6 to 6.0. Another way you could do that, though, is you could put the type float in front of the variable total. What happens then is the computer looks up the number in total, which is 50. It then takes that number, that value, changes that value to a floating point, and then it performs the division. That way here we get normal floating point division, and the answer that's stored in result is not truncated, it's the full answer, okay? So this is known as casting. You are explicitly forcing the computer to do what you want it to do, which is change the type. Okay, so let's go back here. We had this example where I claimed that the division, right, 3.875 is the answer, but then when you try to shove it down into this variable, it's not going to happen. It would require an explicit cast. So let's see how we would actually do that. So I would have to say int ratio equals, and we had 15.5 divided by 4.0. Okay, in this case, instead of making it a floating point, I want to turn it into an integer. That way, if the result is an integer, I can go ahead and store it into this variable here. Now, if I change 15.5 to an integer, but I don't change 4.0 into an integer, it's still going to be normal division. Similarly, if I change 4.0 or not 15.5, it's still going to be normal division. Really what I want is I want to compute this, right, using floating points, and then I want to take the result and I want to cast the result into an integer. In that case, I'm going to have to use parentheses. These, by grouping this with parentheses, you're using, again, order of operations. So I'm saying, please execute this first. That's 3.875. Then take that value, cast it to an int, which is going to get rid of the 0.875, and take that resulting 3 and store it into this integer variable, okay? So your book talks about 3 ways of changing the type of a value. One of those ways is known as casting. And casting, you cast by putting the forced type in parentheses in front of whatever quantity it is that you want to change. That quantity could be a single number or variable, or it could be the result of an expression. You could change the type of the result of that expression. And I'm showing 2 examples here. Okay, so that's basically it. Let's do a quick recap. So talking about arithmetic expressions, most of these operators are what you would expect them to be. The remainder is probably the only new one, and you can use parentheses to enforce order of operations. In terms of division, the type of the number is going to change whether you're performing normal division or integer division. And the rules are over here. If both of the operands are integers, keep in mind you are doing integer division. Integer division will truncate after the decimal place. Also, so that's kind of the right-hand side, right? Normal division, integer, integer. Also, you do need to think about, this is not just for division, but in general, you do need to think about where you're storing the answer. Okay, so if you're storing the answer into a type that has less precision, you may need to cast. Or if you're storing the type in a type, if you're storing the answer in a type that has more precision, an automatic conversion may happen. The remainder operator returns the remainder after division is performed. And again, the 2 uses are isolating digits and testing for even odd, so you'll get a chance to use the mod operator. And then last but not least, in terms of, for constants, anytime you have the value that's a value that's not going to change in your program, you're often better off indicating that fact by making it a final variable. In that case, you would put final in front of the type, and then you want to spell it with all caps and use underscores. Once you do that, you can no longer change the value of that variable. Again, your book talks about a lot of the benefits of doing this, and you should be aware and understand those benefits. Last but not least is casting. So one way to change the type of a value, not a variable, but a value, is by casting. Casting is explicitly putting the type that you want in front of whatever quantity that you want to change. One last note, some computer scientists are not really big fans of casting because you are literally, there are checks in the compiler to make sure you don't mess up. And when you cast, you're actually turning off a lot of warnings and error messages. And some people are uncomfortable with that. But as long as you know what you're casting and you're not casting to try and get rid of an error, but you actually know why you're casting, I think it's a pretty safe thing to do. Okay, so that is that. And with that, we will end.